Okay, for exercise, to know if a reaction is exothermic or endothermic. If enthalpy is positive, it's endothermic. It takes energy from the surroundings. And if enthalpy is negative, it's exothermic. It takes energy to the surroundings. Okay? Exercise 2. There is one example there. And then with that data, you have to calculate the enthalpy for that reaction. That is, okay? So you have to add all the enthalpy in the products. SO3 is minus 395.7 minus the enthalpy of the reactants. SO2 would be minus 296.8, and the enthalpy for elements is 0. Okay, so the only thing you have to do is this operation. Please, you can use the real code application, download it at home if you don't have internet access here, because it's really a calculator, a scientific calculator, not the other one that comes with Android. Okay, so that would be exothermic. Okay, it's important to write the units. Easy. For elements like O2 is 0, and if I don't put it in a table, it's 0. Okay, can I go on? Next one. It's the same. This is entropy. This is an error. It's not enthalpy, it's entropy. And you calculate it the same way you calculate entropy, okay? The only thing you gotta do is to subtract 130 minus 120, okay? It would be 10. Okay? The units. That's the entropy, okay? For what? No, it's joules, only joules, okay? This is a unit, joules per mole, okay? It's entropy. Exercise 4 is to calculate Gibbs free energy. An example of a table. Here you have an example. The formula is Gibbs free energy is enthalpy minus temperature in Fahrenheit times entropy. Okay? So here it would be very important. The temperature here is in centigrades. You have to turn it into Fahrenheit. Just adding 25. Okay? And here, this is in kilojoules. You have to multiply by 1,000. Would be that. Okay? So it would be minus 92,380 minus temperature 298 times entropy minus 198.2. Can leave this number here, add, make this operation. Two 198 times 198.2 is minus 92,380 would be minus 33,316.4. It's negative, meaning that it's spontaneous. Okay? Gonna wait a little. So you can copy it. Okay, can I go on? Can I go on? Okay, I go on. Example. Step 1, calculate the molecular mass for Na, would be 23, okay? It's an atom, you don't have to add. Then you calculate how many moles, that would be 69 grains times 1 mole of sodium is 23 grains, so you got 3 moles. And to calculate the energy, you got 3 moles sodium when 1 mole of sodium reacts to give 411 kilojoules. Okay? That's all you gotta do. It will be 1244 kilojoules of energy. Sorry, step 3. So first you got to calculate the molecular mass. This case is very easy because you have just one atom, so it would be 23. Then you calculate the number of moles, just dividing the grains by the molecular mass. 23, you got 3 moles. Then to get the energy, the only thing you have to multiply the number of moles by the enthalpy of the reaction, okay? Because 1 mole of sodium gives 411 kilojoules, okay? So 3 moles, you just have to multiply by 3 and you get 1244.